Hi guys, Dr. Diaz here again. This problem I solved it a moment ago with the PowerPoint that we have. I wouldn't solve it then again because I did it on the PowerPoint and it looks a little bit sketchy. You probably can see it well. So let's go back again to this problem. Remember, they want us to calculate the net force, the magnitude and direction. And we have three wires here. The length of the wire is 50 centimeters or 0.5 meters. And look at the currents. The current for the first wire goes in to the right, this one goes to the left, and this one goes to the right. Now, if you remember, current that goes in opposite direction, they will experience electric repulsion, right? And if they go in the same direction, they will experience attraction, right? Electric attraction. So in this case, the first one against the second one, it will feel repulsion, and it will go in this direction, right? Because now this one is the one who tells you the direction. This will be the force that we call the force of the cable one due on the second cable. Now if we look at the first one, the last one, that force, it will be in this direction, and it will be the force of the first one due on the third cable. Because the first cable and the third cable, they are 4 centimeters apart, the force is going to be slightly small. And this one, the first with the second, because they're relatively close, the force is going to be much stronger, at least stronger than this one. And you can see here the direction of the force of these two would end up being in the positive side or looking up, right? So let's do it here. Let's calculate first the force due on the first cable, due to the second cable, right? Oh, let's say the force on one due to the second one. And in this case, well, if you remember the equation was, let me write it here. Force will be F is equal to mu, permittivity, the current of the first wire, the current of the second wire, times the length, all then divided by 2 pi a, which is the distance between the two cables. So in this case, it's going to be 4 pi times 10 to the minus 7 in its unit, which is Newton, Tesla, Newton ampere square, or Tesla meter divided by amperes. You can see in the PowerPoint all the units you can use. But here we're going to use the 4 pi because we know that the units of this is going to be forces newtons, times I1, which is 10 amperes, times I2, which happens to be 10 ampere. The good thing is all the currents in these wires are the same, times the length of the cable, which is 0.5 meter, and all of these divided by 2 pi times the distance between cable 1 and 2, which is 2 centimeter, will be 0.02 meters. And if we use a calculator, it's going to give 5 times 10 to the minus 4 newtons. Good. Now we do the cable, the force that is due on the third wire. It's going to be the same equation, but the only thing is, well, the constant is going to be the same, times 10 to the minus 4. Let's put the units like Tesla meter divided by ampere. This is 1. There's a bunch of other units, times 10 ampere. And it happens that all currents are the same, 0.05, and all of these divided by 2 pi times, what is the distance now? The distance from the first to the third cable is not 0.02. It's 0.02 plus 0.02 is going to be 0.04. And if we do this, you're going to get something like 2.5 times 10 to the minus 4 Newton. But because this force we put here is looking in the opposite direction, we're going to call this one minus 4.24 because it's negative here. Now if you want to calculate the net force due to the first cable, the net force on the first cable due to the other two cables is going to be what? F12 plus F13, and this is going to be what? 5 times 10 to the minus 4 newtons plus minus 2.5 times 10 to the minus 4 newtons is going to be positive 2.5 times 10 to the minus 4 newtons. Great. Excellent. Now, the problem also, when it says the net force on each wire, we're going to do the same process we did for F1, but also now for the cable at the middle. Now for the cable in the middle, look, we're going to find how much of the force that exerts the first one, the second with the first cable, and the second with the last cable. So let's do F with 1, 2. So we're going to calculate this one. F, or the force of 2 due to 1. Right? Now this one against this one, look what had happened. This one is cable 2 is the one who's going to tell you the direction. That's why we're doing the first with respect to cable 2. And because they have different direction, the direction of the force will be in this direction. This is F21. It's running away. The cable, the covering here, and cable 2 basically is running away from 1. Now if we look 2 with 3, they also go in the opposite direction. So F23 goes away from it, right? F23. So they're both running away from each other. Oh, but look at this one. You know what is going to happen? Because they are the same current going through each wire. At the same distance, this force is going to cancel out. And I can tell you right away that this force, or F2, I'm sorry, this one is not 0. F2 is going to be 0. Now, this is not 0 yet. Sorry about that. F1, or F21 is going to be what? 4 times 4 pi. Forget that. Look at that. Magically everything is clean now. Well, F21 is equal to what? It's going to be 4 pi times 10 to the minus 7. The units, you remember which one? Times 10 amperes times 10 amperes times the distance, which is 0.5 meters, and all of them divided by 2 times A, 2 pi times the distance, and the distance between the cable's second and the first one is actually just 0.02 meters. And if you do this, the answer is going to be what? 5 times 10 to the minus 4 newtons. And because 2 with 1 is going away, this is actually negative 5 times 10 to the minus 4 newtons. If we do F2 due to 3, we're going to have the same equation. It's going to be 4 pi times 10 to the minus 7 times 10 ampere times 10 amperes times 0.5 meter, and all of them divided by 2 pi times 0.02, you will get exactly the same answer, 5 times 10 to the minus 4 newtons. But because F2, this is actually F23, I forget that, F2 due to 3, because they have repulsion, it will go away from that for 3. So it's actually going to be positive. So F2, which is going to be F21 plus F23, well, we have it, negative 5 times 10 to the minus 4 newtons plus 5 times 10 to the minus 4 newtons. 0. And finally, we're going to find now F3. And F3 is going to be the same as F1 but with different signs. Because this is what happened, right? F3 with F2, because they go in opposite direction, the force is going down. Right? This is F32. And F3 with 1, because they go in the same direction, it will go looking for it. F3, 1. But because the distance between 3 and 1 is bigger than from 3 to 2, this one's going to be much smaller. You can do this, guys. F3, 1 is going to be, well, 4 pi times 10 to the minus 7. Okay, guys, I tried to save time here, so I already did the problem without telling you what I was doing. Okay, but you know, it's actually the basically the same process. Now look at here. F31 is positive, which is this one, but F32 is negative, so it's this. So if you add now F3, which is going to be F31 plus F32, this is equal to what? 2.5 times 10 to the minus 4 newtons. Minus 5 times 10 to the minus 4 newtons. In this case, it's going to be what? Minus 2.5 times 10 to the minus 4 newtons. In other words, it's the same as 1, but negative sign. See you next time, guys.